tried to make a workbench out of a piece of plywood on stacks of blocks, and the blocks crushed under their own weight. So you don't want to build a house like that in an earthquake zone. We tried a second supplier. They were better, but they still crushed. And we were, to use them for a workbench, we put down 2 side by side and 1 across the end, piece of 1/4-inch plywood, and 2 from the other end with 1 across the end, staggered, like brick bond, that kind of a deal. And we stacked them up about, they were 5-inch blocks, so I guess it would have been 5 high, maybe 6 high, to work off of. We were painting rebar, so we needed to get them up off the ground where we could just roll them across. You'd be going along, all of a sudden, boom, and you hear this crack, and one pile of them would go down a block. It was unsafe. So anyway, we went to poured concrete just because it was, and it's not really more expensive. You would think it's more expensive than hollow blocks. The reason hollow blocks are cheap is because there's no cement in it. That's the most expensive part. So they leave out the most expensive part, and therefore profit goes up. So when you put up hollow blocks, you fill the cores full of either mortar or better yet now, small gravel and cement, an actual concrete for the cores. But that's not done much. You hardly ever see it. All you see is dumping mortar in there. Same mortar they lay the blocks with. It's not very resistant to anything. Let me see how many minutes we at. Okay, still all right from. Oh yeah, much better than what I've been doing. I don't understand that. There's an extra number there. Hollow blocks. Okay, so if you take the mortar it takes to lay the hollow blocks, and you have to have 2-finger or 3-finger wide joints here and there about every 3rd course, because you have horizontal rebars. And then you're cutting vertical rebars, and about every 4 courses you stick them in 1 course, and as you build the wall up. So you got the rebar. It's almost as much as I use in the poured concrete time you add it all up. And then you put the render on it. And the render is 4 sand to 1 cement. So you take the cubic feet of total wall, and the amount that's used in the cores and the amount that's used on the render, and it's all richer than the cement that we use for our poured concrete. We're 2 sand, 3 gravel to 1 bag of cement. They're 4 sand to 1 bag of cement for mortar and for render also. So if you add up the total cement in a wall, and the amount that the gravel costs for the block versus the cubic dimension of a gravel and sand that's in a square foot of wall, it's not a whole lot different. And we spend a day putting up forms. We tied all the rebar for the entire floor in 2 days. We just stacked them up. I laid some notched boards out on the concrete, dropped the bars in them, throwed the top bars on it, and had notched bars that fit over from the top down over them. And we just shoved the boards back and forth till the bars pop up in them. And then we got a external shape drawn with Architect's paint markers for the dimensions we're trying to make a rebar grid for. So laying it out ready to tie, yeah, it's way less than 10 minutes, but probably more than 5, because you got to cut a couple for splices, 16 inches of overlap splices. Anyway, we tied all those ahead, so when we stood the forms up, you stand the form up, you stand the rebar up, you put the 1/2-inch threaded rods through for the forms. When they're sticking through about 2/3 of what the pipe sleeves are for the spaces of the wall, you put the pipe sleeves on, then you stand the other side up and put the bolts in it. So it takes a day to set a form up. But that doesn't take care of the ends. The ends someplace. And you have to totally seal that up. So we allow a day for that. And we had 2 guys that was their specialty. At least it was after the first 2 weeks. The rest of the guys are bringing the gravel and sand up and the mixer right to where you're going to pour, right beside it. Close as you can get it without it being in the way. So then we have a pour day, and then we have a day of filling bags of sand and gravel where everybody does it. Day after that, when we get to around 48 hours after the pour, then we strip the forms. Wait too long, they're stuck. Wait too soon, you lose surface water and you get cracks in the cement. So when you take the labor and the materials, in my point of view, it could go either way. You know, so we just went with the poured concrete. And the benefit is our concrete is 8,000 pound per square inch mix. We probably got about 4,500 out of it. To make sure the vibrator can eliminate honeycomb, we're running 10% over on water. The water weight ought to equal the cement weight, and we're a half a bucket of water over top of what's supposed to be in it. But to get it to go down around in that 3 bars of cover between the bar and the form, we have 1.5 inches and 3/4 gravel. But sometimes 1 or 2 pieces will get just right, and then to hold up something behind it, you got a void in the concrete. But if you got that little bit extra water, which is killing your strength, you're losing 1/3 of the strength of the wall. The vibrator jostles it around and it all falls down to the bottom and it comes out pretty. So we just went with a much stronger mix and watered it a little bit and ended up with well more than the 3,000 that is required. Anyway, if we did it again, we'd do it the same way. We're building a dirty kitchen. We're going to pour that too. That's coming up soon. That'll be live videos. This presentation of the big concrete house build Philippines or in the Philippines, that channel. We have live videos on site. We're going to have these look at the computer videos that shows, in this case, we're doing building permit sheets. But we'll also strip the concrete off of a post or a column and show all the stirrups and where they're at, and where the bends and the bars are, and each individual piece. Easy to do in CAD because it's all drawn, and you just keep adding to the drawing. You draw the first one of a bar and one of a stirrup, and then everything else after that is editing. It's you build the drawing by editing. Turning a flat shape into a 3-dimensional thing, you just extrude it. You can extrude it, taper it, and twist it, and all kinds of different things, but you basically didn't have to draw it over. The computer just stretches it to the right height. You draw a line, it puts a surface in it. I mean, they say computer aided. It's a real aid. It's handy. And then we can go back and see what we did, you know, because you can't see into the concrete. Like if I had to know whether I had 16 rebars in a post or 20, I can't count them on the roof anymore. Because when we went through the first floor, which would be actually, it was really the roof, we bent down all but 6 of them into the floor slab. And that left a lot less sticking up, you know, to add on to. But we can count those on part of it. But if I wanted to know how many total there was, or where they were, so I didn't drill into them trying to put an electrical box, I can go back to this, and everything is right where it is on the drawing. We didn't camp on accuracy, but we did make it as close as we could get it without having to waste a whole bunch of time and get everybody upset. I don't think they get mad at me. I don't know. I don't think that. I think the easygoing people, they smile and they laugh and they sing sometimes when they work. And it's like family. You know, we just adopted the whole bunch of them. Okay, so we have flogged this one until it can't do anymore. So let's turn this off. Maybe we'll go find another video here. Actually, I need to go to the site. I don't know if these videos are going to work to YouTube, and but I'm gonna do a dozen of them, and then we're going to try to get a channel and start sticking them up. See what happens. I got the pictures for the slideshow. I just need to put them in groups that are the same thing. You know, like dealing with footers or dealing with wall outlets or dealing with some aspect of it. Oh, if you don't learn anything else from this channel, listen up, everybody, listen up. You have got to have conduits for internet, CCTV, all those electronic services. We're our own contractor. Our people are fishermen and farmers. So it was nobody to tell us the CCTV has to have a conduit. Here we are with 1,500 feet of conduit and not one piece for a camera or for internet. And that's going to be a pain in the butt with wireless everything and channels getting mixed up, and it's just going to be ugly. We're going to put it off till the last minute. We're going to be leaving the house before we worry about any of that. But remember, CCTV, you have got to have conduit. And if you have anything else that's odd, like if you have elderly in the house and you have a central oxygen bottle and a regulator by the bed or something, you need someplace to run that hose. You know, so just make sure you have a conduit for all the weird stuff. Okay, end of this one.